Just take a quick look around you right now. Seriously, the phone in your hand, that bottle of water on your desk, maybe even the chair you're sitting in. Plastic is absolutely everywhere, and it takes on any shape, any color, any texture we can dream up. But have you ever really stopped and wondered, how? How does it get that shape?
I mean, how does some raw, formless material become something so incredibly precise and useful? Well, today, we're going to pull back the curtain on the amazing engineering that turns raw plastic into all the things that, kind of shape our world. Let's dive in.
The journey from that raw material to a finished product is pretty wild. Whether we're talking about a simple plastic bottle or a super complex part inside a car, pretty much every single plastic object you can think of starts its life in the exact same, surprisingly simple form.
Yep, that's it. Little plastic pellets. Before it's a car bumper, before it's a keyboard, it's just a bunch of these tiny little beads. This is the universal starting line. So the real magic, the real question, is how do we get from these to, well, everything else?
All right, so our first big method is all about making shapes that are, well, continuous. They just keep on going. It's a process called extrusion, and it is behind a huge amount of the plastic we use every day.
You know the easiest way to picture extrusion? Think of a pasta maker. Seriously, but for plastic. You dump the raw pellets in, they get heated up until they're this thick, molten goo, and then that goo gets squeezed through a special shaped opening. It's called a die. Whatever the shape of that die is, that's the shape of the plastic that comes out, in one long, endless piece.
And this is the machine that makes it all happen, the screw extruder. Those little pellets go into the hopper on the left. And from there, this giant rotating screw just pushes them all along a heated barrel, melting them and mixing them as they go. Now that one single screw is actually doing three really important jobs. The first part, the feed section, it just grabs the pellets and moves them forward. Then, in the melt section, it's all about intense heat and friction working together to turn those solid bits into a gooey, molten mess. And finally, the metering section, that acts like a powerful pump, building up a ton of pressure to force that liquid plastic out through the die in a perfectly smooth, uniform stream.
Now, extrusion is obviously perfect for things like pipes or window frames, but what if you need something that's not just long, but also really thin and flexible? Well, this same process has a pretty clever trick up its sleeve for making one of the most common plastic items on the entire planet.
Believe it or not, a plastic shopping bag starts its life as an extruded tube. It gets pushed out of the die pointing straight up into the air, and then air is blown right into the middle of it, inflating it like a giant continuous balloon. Now this stretching does two things. First, it makes the plastic super thin. But more importantly, it lines up all the plastic's molecules, and that's the secret to why a flimsy little bag is surprisingly strong.
Okay, but not everything is a continuous tube or a long pipe, right? Most of the plastic things in our lives are individual items. A phone case, a toy, you name it. To make those, you need a totally different approach. You need molding.
And that really is the fundamental difference. Think of extrusion like you're drawing a continuous line, but molding is like you're filling in a specific shape. Extrusion is for stuff you sell by the foot, while molding is for stuff you sell by the piece. One makes the garden hose, the other makes the spray nozzle.
Now, the undisputed king of molding is injection molding. This is how we get all those detailed, solid parts like Lego bricks or the casing for your TV. The best way to think of it is like a super-powered, high-tech hot glue gun. It melts the plastic pellets and then injects that liquid into a steel mold with just incredible force and speed. The plastic fills every nook and cranny, cools almost instantly, and pop, the mold opens, kicks out a perfect part, and is ready for the next one in just a few seconds. Injection molding is fantastic for solid things, but it can't really make something hollow like a bottle or a milk jug. I mean, you can't just inject plastic around an empty space. For that, engineers had to get really clever.
And the solution is called blow molding, and it is brilliantly simple. It happens in 3 super fast steps. First, a little hollow tube of hot plastic, it's called a parison, gets extruded straight down. Second, a bottle-shaped mold clamps shut right around it. And third, a jet of air shoots in and inflates that soft plastic tube, pushing it out against the cold walls of the mold. The plastic hardens on contact, the mold pops open, and out drops a perfect hollow bottle.
So let's just do a quick recap of the big 3.
You've got extrusion for your continuous shapes, like pipes. You've got injection molding for making really complex, solid parts at crazy high speeds. And then you have blow molding for making all the hollow things, like bottles and containers. Each one is a specialized tool for a completely different kind of job.
Okay, so we've covered solid shapes, continuous shapes, and hollow shapes. You'd think that's everything, right? Nope. Plastic has one more incredible trick up its sleeve, a transformation that you are probably wearing right now.
Exactly. Just think about it. That polyester shirt, a nylon jacket, maybe even the carpet on your floor. That's all plastic. But it wasn't molded or extruded like a solid object. It's made of billions and billions of tiny little fibers.
This process is called melt spinning, and it is so cool. Molten plastic is forced at super high pressure through a metal plate called a spinneret, which is just full of hundreds, sometimes thousands of microscopic holes. As these tiny little liquid streams shoot out, they hit the cool air and instantly turn into solid, continuous threads. It's almost exactly like a spider spinning a web, just on a massive industrial scale, creating endless strands of plastic thread all at once.
And these incredibly fine filaments, well, that's the raw material for basically the entire textile industry. They get twisted together to make yarn, and that yarn is then woven or knitted into the fabrics for our clothes, our furniture, our carpets, and so much more. Just think about that for a second. It's the same base material as a plastic bottle, just transformed in a totally different way.
So from a simple, humble pellet to this endless variety of forms, we've seen the fundamental ways that plastic gets its shape. Let's just bring it all together.
You know, when you really boil it all down, it's surprisingly simple, isn't it? Nearly every plastic thing starts as that little pellet. From there, it's either extruded like pasta into long shapes, it's molded like clay into individual objects, or it's spun like a spider's web into tiny fibers. Just 3 core ideas are responsible for pretty much the entire plastic world that we live in.
And now that you know the secret, you're going to start seeing it everywhere. You'll look at a container and think, is that blow molded? You'll see a piece of trim and wonder if it's an extrusion. The hidden story of how things are made is all around you. So what are you going to notice first?